Lesson 6.3 talks about how to solve a system of equations by graphing. So as we've already discussed, a solution to a system is where the two lines intersect. So if you take a look at this system, they intersect right here. And so when it asks for the solution, remember that the first number in the set of parentheses is your x, and the second number is your y. So we're going to take a look at this point here. We're going to find the x value of it. So you go to the x-axis. The x value is 4. So we're going to put 4 in there for the x value. And then we have to follow it over to the y-axis as well to find the y value. So if you can see that there, it's in between this line and this line. So this is 4 and this is 6. Right in the middle is 5. So the y value is 5. And our answer, our solution, is the point 4, 5. If you think about what we did yesterday with seeing if it works, does 4 for x and 5 for y work in this equation? So if x is 4, 4 plus 1 is 5, so that works. Here, if x is 4, that's 12, and 12 minus 7 is 5, so that works. So 4, 5 is the solution. If you take a look down at the got it, the solution is right here. So you would put the answer in a set of ordered pairs. So the x value, you follow that to the x-axis. The x value is -2. And the y value, you follow over to the y-axis, and that's -1. So the solution to the got it is the point -2, -1. And that has to go in parentheses. On this next page, what you're asked to do is graph each line in order to determine the solution to the system. So we're going to remember that y equals mx plus b is slope-intercept form. So here I have a plus 0, so my y-intercept is 0, and my slope is 2, but we're going to write it as a fraction, 2 over 1. So 2 over 1 tells me to rise 2 and run 1, rise 2 and run 1, so I'm going to the right because it's positive. I'm also going to go down 2 and left 1, and then I'm going to draw my line. Make sure you use a straight edge to do that. And now I'm ready to graph the second line. So with the second line, my y-intercept is 4, so I'm going to plot the y-intercept of 4. And then my slope is -6 over 1, so from 4 I'm going to go down 6 and right 1. And down 6 again and right 1 is off my screen, so I'm going to go ahead and connect those dots with a line. And as you can see, this one is not as neat of a solution as the other ones were, but the answer is where they intersect, which is right here. So the x value, I'm going to go ahead and approximate that. That's about 1/2, and the y value is 1. So my solution is the point, so we put it in parentheses, 1/2, 1. Moving on to the next problem, my y-intercept is 1 at the top equation, so I'm going to plot the 1 on the y-intercept, and then my slope is up 3, right 1. Or it's also down 3 and left 1. Oops. Down 3 and left 1. So I have my points there, and I'm going to connect them with a line. And now I'm going to graph the second equation, but the second equation is not in slope-intercept form, so I'm going to do a little bit of work to get it into slope-intercept form. I have x, oops, sorry about that. So we have x minus 3y equals 1. So I'm going to subtract x from each side. When I do that, a negative 3y drops equals negative x plus 1. And then I'm going to divide by negative 3. When I divide by negative 3, I need to make sure I divide everything by negative 3. So we get y equals, now remember this number is a 1 in front of that x when you don't see it there. A negative divided by a negative is a positive, so I get positive 1/3 x. And a positive divided by a negative is a negative, so I get minus 1/3. This one's going to be a bit tricky as well because my y-intercept is negative 1/3. So I have to approximate that right about there. And then I'm going to go up 1 and right 3. So it's right about there. Or down 1 and left 3. So it's right about there. So now I'm going to connect the dots. And again, this is not a pretty answer because it's right in between things, but I'm going to approximate that. The x value is just about negative 1/2, and the y value is also just about negative 1/2. So I'm going to say the solution is negative 1/2, negative 1/2, and you always put that in parentheses. You could also write it as negative 0.5, negative 0.5 if you wanted to. This page has application problems on it. So the first one is about buying photographs. And package A is $25 for 12 photos, and then you have to pay 40 cents for each additional print. So the equation for this one would be y equals the $25 plus 40 cents for each additional print. So I'm going to say it's 0.4 for 40 cents times x, which is the number of prints that I buy. For package B, we have $30 for 12 photos, but it's only 15 cents for each additional print. So my equation, the cost y, is going to equal $30 for the first 12 plus 15 cents, so 0.15, times the number of additional prints I get. So now we have two equations that we can go ahead and graph. So we're going to graph the top one, package A, and there are a couple different ways you can do this. I'm going to choose to write 0.4 as 4/10 or 2/5. And I'm going to change the order so it's y equals mx plus b. So y equals 2/5 x plus 25. So my y-intercept is 25. And then I am going up 2 and right 5. Since my scales go the same amount on both the x and y axes, I can just count the squares up 2 and right 5, and I'll be right there. So I'm going to go ahead and plot that point. And that only works because my scales are the same. So I'm going to go ahead and connect those dots. For the second equation, y equals 30 plus 0.15x, that's a little bit different because that slope of 0.15 is 15/100ths, which simplifies to 3/20ths, and I don't have enough room on here, it doesn't look like, to count by squares. So what I'm going to do is I'm just going to figure out how much 40 prints would cost, 40 additional prints I should say. So I'm going to plug 40 in for the 0.15, or for the x, I'm sorry, And so it's 30 plus 0.15 times 40. So that will give me, if I type that into my calculator, that will give me $36. So 40 prints, 40 additional prints would cost $36. So I'm going to approximate that right there. So I'm going to plot that point. So 40, 36 is going to be right about there. And then my y-intercept is 30, so that's easy to identify right there. And I'm going to connect the dots. So it appears that the intersection is right about there. So I'm going to follow that down. It looks to be about 20. And then it's really hard to see where it is here. So if the x is 20, I can plug it in here. So 0.4 times 20 plus 25, that equals 33. So the intersection point is the point 20, 33. So that means that it will cost the same amount if I buy 20 additional prints. So remember, I already bought the 12 right here for that first amount of money, and then I buy 20 more. So it'll cost the same for 32 prints. And then it asks when package A is the better deal. So package A is here, which is the blue line. The better deal is when you buy less than 20 additional prints, or less than a total of 32 prints. Please make sure you write that sentence down before moving on to the next example. In this next example, tickets for a concert cost $10 each if you order them online, but you have to pay a service charge of $8 per order, and the tickets are $12 each if you buy them at the door on the night of the concert. How many tickets must you buy for the concert tickets to be the same? So the two things we're talking about are the number of tickets that we have, So make sure that you write that sentence before you stop the video.